Hi everyone, so today we will discuss about scientific notation. We learned the notation used in science to express very large or very small numbers. So what is scientific notation? Scientific notation is a concise ways of expressing very large or very small numbers. It involves writing a very large or very small numbers as a power of 10. Scientific notation is written if it's in the form of a times 10 raised to n, where a is greater than 1 but less than 10 and n is an integer. So before we start with the scientific notation, let us focus first with the power of 10 and its decimal equivalent. Okay, 10 raised to 4 is actually equivalent to 10,000. 10 raised to 3 is equivalent to 1,000. 10 raised to 2 is equivalent to 100. And 10 raised to 1 is equal to 10. We observe the power of 10 when it's positive. We just count the number of zeros. So if it's 4, we have 1, 2, 3, 4 zeros. If it's 3, 1, 2, 3, 0. And if it's 0, we don't have 0. Next will be when the power is negative. When the power is negative, 10 raised to negative 1 is 0.1. 10 raised to negative 2 is 0.01. 10 raised to negative 3 is 0.001. And 10 raised to negative 4 is 0.0001. So, let us observe when the exponent is negative. When the exponent is negative, the decimal point will be before the number, which is 1. And the number of 0 will be less than 1 to the absolute value of the exponent. For example, this is negative 1. So when it's negative 1, we don't have 0 after the decimal point. When it's negative 2, we only have 1 0 after the decimal point. When it's negative 3, we have 2 zeros after the decimal point. And when it's negative 4, we have 3 zeros after the decimal point. Okay, let us have an example. 1.43, we would like to multiply it to the powers of 10. For example, times 10 raised to 1. We all know that 10 raised to 1 is equivalent to 10. So, when we are multiplying a number which is divisible by 10, we have to move the decimal point one place to the right. So, it will become 1.3. Example number 2. 1.43 times 10 raised to 2. 1.43 times 100 is actually equal to 1. Since we have 1, 2, we move the decimal point to 1, 2. So we have 1, 4, 3. Next will be 1.43 times 10 raised to 4. So we have 1.43 times 10 raised to 4 is equivalent to 1. We have 4 zeros. 1, 2, 3, 4. Okay, if we are multiplying by this number, we have to count how many zeros? 1, 2, 3, 4. So we have to move 4 decimal places to the right. So we have 1.43, 1, 2, 3, 4, 0. And it is equivalent since we have empty spaces, we have empty space here, we add 0, so it will be equivalent to 1 4 3 0 0. Next, 1.43 times 10 raised to negative 1. So we have 1.43. It is actually equal to 0.1. Since this is negative, instead of moving the decimal place to the right, we have to move the decimal place to the left. So we have 1, since we have 1 decimal place. So it will be equivalent to 0.143. Next, we'll be writing in scientific notation. Scientific notation is a shorthand way of writing numbers using power of 10. So let us have the writing. Okay, for example, we have 3,200,000,000. So for us to write it in scientific notation, we have to take note of this. Notation A times 10 raised to n, where A is always greater than 1 but less than 10, and n is any integers. Okay, first, you have to identify where is the decimal point. So for this one, this is the decimal. Second is to identify where we're going to move the decimal point to become A, which is greater than 1 but less than 10. So if I'm going to put the point here, it will become 0.32. It is not greater than 1. If I'm going to put here, it will become greater than 1 but less than 10. If I'm going to put the decimal point here, it will become 32. It will become greater than 1 but it is not less than 10. So it should be here. So move 9 places to the left. Okay, when we move decimal places or 9 decimal places to the left, the exponent will be positive. So it will become 3.2 times 10 raised to 9. Another example. Let's check where is the decimal point. So if we're going to put the decimal point here, it will become 0.175. So it is not greater than 1. If we're going to put here, it will become 1.75. It is greater than 1 but less than 10. So good. Let's move the decimal point. We move 10 decimal places to the left so that the exponent will be positive. So it will become 1.75 times 10 raised to 10. Okay, next example. Let us convert this in scientific notation. Identify where is the decimal point and where we're going to put the decimal point. If we're going to place the decimal point here, it will become 0.7. So it is not greater than 1. If we're going to put the decimal point here, it will become greater than 1 but less than 10. So move decimal point. So we move 7 places to the right. So when it's right, the exponent will be negative. So it will become 7 times 10 raised to 7, and it's negative. Number 4. So first, identify the decimal point, and we're going to put it here. So count. So we have 8 places to the right. It should be negative. So we have 1.42 times 10 raised to 8 negative. Okay, next, we have to change scientific notation to standard notation. What is the difference between the scientific notation and standard deviation? Scientific notation, those numbers that we use power of 10. Standard notation are those decimal notation we normally use, like for example 1.1, 0.3, and so on and so forth. So let us have an example. For example number 1, we have 3.5 times 10 raised to 11. In changing scientific notation to standard notation, we have to move the decimal point in the first factor to the number of places indicated by the exponent of the power of 10. What is the exponent? We have 11. So we have to move 11 places. Since this is positive, we move the decimal point to the right. For example, we have 3.5. Move the decimal point 11 times. So fill everything with zeros and rewrite it. So we have 3.5. So this is the answer. Another example, number 2. So where is the decimal point? Here we have to move 15 places. Positive is the exponent, so we have to move to the right. So we have 4. Next, number 2, 1.8 times 10 raised to negative 7. So first, you have to identify where is the decimal point and count how many places. 7 places. Since this is negative, we have to move to the left. So we have 1.8 another example. So this will become, this is the decimal point. We have 13 places. This is negative. So this will be to the left. So we have 5. And thank you for watching until the math video tutorial.